Hi, in this tutorial we are going to solve some questions related to diels-alder reactions. Let's start solving the problems. In the first case, we have a diene here and we have a dienophile, and we are going to write the corresponding product here. So it's always better in this type of questions to label or number the atoms so that you can follow the reaction. Let's start from the diene. Let's say this is number 1 carbon, number 2, number 3, and number 4. And for the dienophile, I'm going to number the alkene part as 5 and 6. Then you know that the diene is going to make 2 new sigma bond with the dienophile, and we are going to form a new pi bond in between 2 and 3. So I'm going to use dashes to make that sigma bonds. Then we can write the real product in this part. So number 1 carbon is going to make a bond, make a sigma bond. Let's write it here with number 5, and number 4 is going to make a new sigma bond with number 6, and here between 2 and 3 I'm going to write again a new pi bond as a dash. Then we can write here the resulting product. Let's here move. Okay, so like when you write the products for diels-alder reaction, you have to count, or you have to predict what is going to be your product. Since we are adding 4 carbon and 2 carbon and we are connecting them, so we are supposed to produce here a cyclohexene. So let's draw the structure of cyclohexene here. This is going to be our new product. Then we can say that there is going to be here a double bond, and then let's number again the positions. This was number 1, number 2, 3, 4, 5, and 6. Follow from the dienophile. Number 6 should have a methyl group. So just let's write here the methyl group as CH3. Here number 5 has an ester functionality. Number 6 or CH3. If you look at the structure, actually the structure does not reflect the stereochemistry of the product, since we started with a like cis alkene here or E-alkene. The product, the resulting cyclohexene, should reflect the same stereochemistry. So let's just correct here the stereochemistry. And these two groups, methyl group and ester group, should be cis to each other in the new product. And we can just use maybe dash dash or wedge wedge. I prefer dash. Let's say this is ester and this is going to be the methyl group. So this is the answer for the first question. Since this molecule has here an internal symmetry plane, so it's a meso compound, it doesn't matter whether you draw dash dash or wedge wedge, it's going to be the same molecule. So we don't have to write the second molecule. Okay, let's move to the second reaction. In the second reaction, again, we have here a diene, 1-tributadiene. Here, as an alkene, as a dienophile, we have the same actually with the first question, but methyl and ester groups are trans or or E with respect to each other. So again, without explaining too much, because it's the same, Let's just number the carbons the same way. 1, 2, 3, 4. This is going to be 5 and 6. Then let's draw here the product. Here there is going to be the double bond between 2 and 3, and 1 and 6 is making this bond, new connection, and 4 and 5 making the making new sigma bond. Then we have to reflect here the stereochemistry of the dienophile. It's trans, so here in the new molecule in the cyclohexene, they have to be trans. So I'm going to use dash and wedge. So for the wedge, it's going to be the ester, and for the dash one I'm going to write methyl group. Since we don't have the symmetry plane, internal symmetry plane, we are going to form the other molecule with the trans configuration, but this is going to be the ester with the dash, and the wedge one is going to be the methyl group. So we will have two products. Okay, let's move to the next question. The next question is a little bit different from the first two ones because the diene is a cyclic diene. If you say 1, 2, 3, 1 tricyclopentadiene, and our our dienophile having also like electron withdrawing groups. It's an alkene. It's also cyclic one, so we can follow the same strategy here as numbering the carbons and showing here the new product. Let's again with the red marker, let's number here. Let's say this is number 1, 2, 3, 4, and let's say this is number 5 and number 6, and let's do the same thing. Number 4 is going to make a new sigma bond with 5. Number 1 is going to make a new sigma bond with number 6 carbon. Then so we are going to write similar to this a cyclohexene as the product. But if you look at here, we have here a CH2 group. Let me label this one as CH2, because we have to show also this CH2 when we draw the new cyclohexene. When you have a cyclic diene, generally the correct way to draw the structure is this. You have to reflect the 3D structure on a 2D drawing. Basically, you have to start this way. It's like a book. So this is, let's number again with the red one. So this was number 1, number 2, 3, 4, 5, and 6. So basically, between number 1 and 4, there is a methylene bridge here, right? So generally people draw this way. Let's use the black marker again. It's this. This is the bridge, basically connecting connecting 1 and 4, and also connecting 5 and 6, like between like 1, 4, 5, 6 and methylene, 1, 2, 3, 4 and methylene, because we have a bicyclic structure here. Then we have to show the orientation of the this here an ester. This is cyclic ester. So basically we have to draw 5 and 6. We have to attach this cyclic part again, so we have another cyclic structure there. So let's use again the black marker here. Generally we do this way, down, down. Here the oxygen bridging the diester here, Let's draw a little bit better. Okay, then like you can draw hydrogens also, because there were two hydrogens here. Let's draw like this way: hydrogen, hydrogen. I'm going to show something because there is a reason why we are showing hydrogen. And don't forget, between 2 and 3 there should be a new pi bond. So when you look at here, we have two bridges, one a methylene bridge we have here, and a double bond bridge 2 and 3. So when the big bridge 2 and 3 is on the same side with this the bigger group, bigger R group, because there were here, let's draw H and H. So this ester, cyclic ester part should face downward, or should face the same way as a big bridge. So this product is called endo product. And there is one more possible product. Instead of cyclic ester facing the same way as the this ethylene bridge, it might be with the methylene bridge on the same side, like hydrogen and hydrogen. It's called exo product, but endo product is the major product. So let's see how they look like in 3D from question 1 and question 2 to question 3. I prepared you some files containing 3D structure. So basically, this is the cyclohexene, the resulting cyclohexene. It's not the same groups. Here we have ester, we have here methyl, but I put here methyl methyl. So this is the cis product. So basically, these two groups, or you can say that here ester and methyl, here methyl methyl, they should be on the same side. Why? Because we started with the cis alkene or cis dienophile. Let's look at the second second shape or second model. In the second model, it's the same. It's a cyclohexene. Here we have a double bond, and you see here the big groups methyl and methyl are on the opposite face. Here it's again not the same, methyl and ester, but instead of methyl ester, I just put here methyl methyl just to show you the stereochemistry, correct stereochemistry. So here they are with respect to each other trans. They are trans to each other. And let's see the last question or last model. Here I'm not showing you any hydrogens, but let's just look at here. So basically this carbon is this methylene bridge. This is the carbon-carbon double bond, and here we have the ester group, and ester group and the carbon-carbon double bond or ethylene, they are on the opposite or they are facing opposite side. So this is the exo product. So we say that this is not the major product, this is the minor product. And let's look at the endo product. This is the endo product. Basically this one is the same as this one. As you see, this is the ethylene, this bridge, and this one is the methylene bridge, this one here, CH2. And the ester part, cyclic ester part, is facing downward as similar to this carbon-carbon or ethylene bridge. So this is the endo product, and we say that this one is the major product. Okay, we solved 3 questions related to Diels-Alder reactions. Thank you so much for watching.